Okay, scripture time. Got a quick video. So I can get it to go. Here it comes.
Did you watch last night's episode?
No, I got home late.
She went to school the next day, and I heard that she's no way. Seriously, are you surprised? Do you not know Carly? Have you seen what she wears?
Girls, let's cool it on the gossip, okay? It's not right. We'll get enough problems.
What do you mean?
Well, her mom can't get through soccer practice without a thermos of Chardonnay, and don't get me started on the dad, that guy.
Such a dangerous intersection. Did I get lipstick on my face? No, you're fine. And consider yourself lucky you didn't just get felt up by your mom. They need to get a stop sign. What's your obsession with traffic? It's an obsession with safety. One of these days, Joe Speeder's going to come tearing through here, and someone's going to...
Okay. Guys.
Still?
Yeah, I'm good. Gotta keep moving. Keep the heart rate up.
I don't know what that.
Still good.
Okay, did y'all see anything that was dishonest? She lied to her sister. What else? They were gossiping. Even though the mom said don't do it, she started doing it even more. So, what's our lesson? Honesty is the best policy, and it's written right here in Exodus. Let's have Aviana. You read this. Please.
Do not spread false rumors. Do not help victims by giving her false testimony.
Very good. So, don't spread rumors. That's a given, right? This says false rumors. I don't think you should spread any, should you? Hey, Gilbert, did you hear about Mackenzie? She got 100 on her homework. Okay, you shouldn't talk about people in general. But then what about this part? What if it's your best friend and you want to get him out of trouble? Aviana, who's your best friend? Vinny? Okay. Think of something horrible that Vinny might have done. Just give me anything. Anybody. Oh, Vinny's a girl?
Yeah.
I had no idea.
Her name's Vincenza.
Oh, Vincentia. Okay. All right.
Like, smile, do something like.
Well, Mackenzie said she killed somebody.
Okay, she killed.
All right. So let's say Vinny's driving along one night, and it's Halloween, and the trick-or-treater runs out in front of her car, and she runs him over, and she's like, "Oh no!" And so she takes off. Okay. A witness saw a car that looks just like hers. And so the police come and they are going to arrest her. But before any of this happens, she gets you, Aviana, to alibi for her. So you're going to tell the police that she was with you, and none of that ever happened. Is that a good thing or a bad thing? That's horrible. So you should not help a guilty person by giving false testimony. Okay, guys. Shh. Quick poll. Actually, it's not a poll, just random questions. Who here has a job? All right, Lucas, what do you do with your paycheck? And then what do you do with it? What percent? Holy moly, okay. Yeah, that's good. That's good for you, okay. Anybody else? Oh, Emily. You have a job? What do you do with your paycheck? Oh, nice. I love it. They're preparing you for what's to come in a new socialist world where you get every fourth of your paychecks. But the government will take care of you. They'll buy your gas and stuff. Okay. I actually quit listening. How much of your fourth paycheck do you save and spend? How much of your fourth paycheck do you spend?
I mean, I get
Yeah, but do you save it or spend it? Or both?
I say freeze.
Okay. All right, never mind. Okay. Who else has a job? That girl? Valerie,
Yeah.
what percentage of your paycheck do you save and spend?
I mean, I have a savings account that was 8, and I have about $400 in it for the past like 8 years.
Oh, okay.
So I guess I can say that. My mom makes me like put $20 every week into it, so it says like 10% maybe.
Okay.
10% of it is in the savings account, I guess. And
All right. All right, who do you think's more representative of society, Lucas or Val? Val. Val, definitely. Yeah, we're going to examine that today in class. But first, let me tell you what's going on. Oh, here's something. Okay, this is a danger in society. What's Halloween? It's next Friday. Okay, pumpkins get a little bit rowdy. Have y'all ever woken up the next day and you see pumpkins just smashed everywhere? Mm-hmm. Well, check this out. When pumpkins drink too much. That's actually, this is something you need to be aware of. Okay? If you ever find yourself as a pumpkin, don't drink. All right? All right. Then another Halloween funny. This guy's taking their candy so he can give it to the kids that are too lazy to trick or treat. Okay. So, guys, today we got new stuff. Okay? And it's a little bit tricky. It's extremely simple, but for whatever reason, it just comes across complicated. Okay? We're going to do a lot of math today, and that math is going to be dealing with what percentage people save and spend, okay, and how that affects the economy. So let's see. We've done our journal. Y'all are going to take a quiz today. Yay! Okay. You're going to take a quiz. You have 2 homework assignments. Kia 4-4A, it's about multipliers, which is what we're learning today. And then the 4-4B vocabulary that will help us get ready for the next class. Okey-doke. So if you don't look so bummed out. So this whole thing with aggregate demand and aggregate supply, we're going to use an analogy that the economy is a bathtub. And the bathtub level right here is considered perfect. This is the same thing as our long-run aggregate supply curve. Do y'all remember that? It's the curve that's totally vertical. It's at the full employment level of GDP, and that's good. Okay? Yeah, it's this line right here. Yep. Okay. Well, let's look at that. Actually, we're not going to have the SRAS with the bathtub here. Instead, we've got some aggregate demand. Okay. So all of this stuff right here fills up the bathtub. Okay. So as we get more consumption and investment in government purchases and exports, all of that stuff's going to fill up the economy, make the bathtub level go higher. Okay. If it gets too high, what happens? Yeah, it overflows. Is that good or bad? All right. Yeah, it's waste. And in fact, we would actually call that inflation. So if it starts to overflow, that's when we get inflation. We don't like that. All right. On the other hand, we have these things that occur. So Lucas, all that saving you're doing, that sure isn't helping the economy, man. No. Okay, the savings, taxes, imports, all of that take away from the aggregate demand. Okay, so all of this is coming out of the drain. And if too much comes out of the drain, then you end up with a recession. Yes, Lucas?
If I invested my savings,
That'd be good. Yeah, and actually, I was making a very big generalization about your saving. The reality is that you saving provides money that businesses can then borrow to invest. So it's good to save. Okay. But you are not directly affecting consumption at all, right? Okay, cool. So anyway, if the bathtub level gets too low, we call that a recession, okay? So we would like these leakages to be equal to these as long as we're at the long-run aggregate supply curve. So far, so good?
You said those amount of things, they're like, this was like the AD.
Mhm.
So what would the leakage?
They would take away from the aggregate demand. So we're really just focused on aggregate demand, okay? So like if we go to this curve now, this graph, okay, the consumption, the investment, the government purchases, the net exports, if we have too much of that, okay, too much of the SIGX stuff, the AD curve shifts to the right, and that's too much. Okay, we don't like that because it leads to too much inflation. Cool with that? Then we have what's called an inflationary gap. Today in class, we're going to learn how to fix that. All right? But then if we have too much Lucas, too much savings, too much taxes, too many imports, then the AD curve shifts to the left. That's equally bad because now we're in a recession. Everybody get this? So that's why I use the bathtub as an analogy, but really I'm not going to give you drawings of a bathtub. I'm going to give you drawings of a curve so that you can analyze it and fix things. All right, are y'all good? Okay, cool. So do y'all remember we talked about Keynes last time? Okay. Well, I want to just point out the big difference between classical theory and Keynesian theory, okay? What we're about to learn is Keynesian, okay? But classical is going to end up being just the opposite. I want to see if y'all can figure out what the difference is.
Government is not the solution to our problem. Government is the problem.
So can you tell right away what classical economics is all about?
Yeah.
No, not in it. No, so Keynes' theory says the government needs to act whenever the economy is slow. So whenever that bathtub is dripping out and there's not enough in it, the government needs to increase spending so they can fill it back up. Okay? The classical economists, like Adam Smith, he said, no, don't do anything. You're going to make it worse. Okay? So we have those two schools of thought. So bottom line, classicals say, leave the economy alone, let it fix itself. The Keynesians say, no, we got to fix it because we need it now. Okay? Okay, so I would say this is just my opinion. I like these guys better. I like the classicals better. Simply because if you look at the evidence, like what, in 2009 we spent $1 trillion and it didn't budge the economy. So, it could be. That's a possibility. It's all theory. It's really hard. It's hard to prove a negative. So it's like, okay, if we hadn't have done it, what would have happened? Who knows? Yeah. But we did spend a lot.
It's like a big, fat, angry slob.
You'll need to figure out what Ron Swanson is. Okay?
You want more pointless social program. Yummy, yummy, yum.
I've been quite open about this around the office. I don't want this parks department to build any parks because I don't believe in government. I think that all government is a waste of taxpayer money. My dream is to have the park system privatized and run entirely for profit by corporations, like Chuck E. Cheese.
All right. Is he classical or Keynesian? See, you got it. That's all we needed to know. No, he believes in money. He's like a billionaire or something. He's got like gold hidden everywhere. That's funny. No, Ron Swanson. He's not a real guy. He's a fictional character.
So I know that, but I thought you meant like the actor. I was like,
No.
Oh, he's probably rich too, but.
Well, who knows? He was a relatively unknown actor until that came along, right?
And he's exactly like that.
Is he?
Yeah, exactly. And actually, it's Teddy Christmas.
I'm thinking for Halloween I'm going to go as him. I'm just going to get one of those big mustaches, slick my hair back. Yeah, I guess. Oh yeah, Tammy. Get some Tammys. Was there 3 Tammys or just 2?
No, oh, like the mom was named Tammy.
Oh, his mom is named Tammy. That's right. Yeah. Okay. I get it. All right. So anyway, are y'all ready to do the math stuff? Okay. So the rest of the class, we're actually going to be learning the Keynesian theory. Okay. He came up with this idea that there's a multiplier in the economy, and that when we spend money, it becomes another person's income, who then spends that income, and so it just keeps on multiplying through the economy. All right, that's what we're going to learn. You have a question?
Yeah, and maybe I showed us last time, like, we absolutely decided that Obama is king.
Yeah.
Why is that an insult?
Oh, it's not an insult. They thought the sign said he's from Kenya.
Oh.
Yeah. So, yeah. All right, here we go. APC. All right, APC stands for the average propensity to consume. So y'all, this is stuff y'all will need to know, okay? Then we have the APS. This is the average propensity to save. Okay? So when you when you have your paycheck, taxes have already been taken out, and what you can do with your paycheck then is spend it or save it. Okay? The percent of your paycheck that you spend is called the average propensity to consume, and the percent of it that you save is called the average propensity to save. Y'all feel okay with that? So to calculate it, let's pretend we have income of $50,000. Of that $50,000 in income, we spend $48,000 of it. That means 48 divided by 50 is going to give us 0.96. So to calculate the APC, we take the consumption, which is the C over here. We divide it by income. So the letter Y is what we use for income. Yes,
So you
so,
take if you get a 50,000 paycheck, you spend 40,000.
mhm. Yep. Yeah, it's 96%. And so we express our APC as a decimal, though. So it's 0.96. Yes, sir, Lucas.
When it's the Y, it's not the Y, that's the graphs.
Yeah, the letter Y, it just stands for income.
Okay.
Mhm. Good job. Okay.
What is C?
C is consumption. Yeah, in fact, y'all should make a little key so that you'll know what all the letters mean.
Oh, and does that mean savings? S means savings?
Yep. Lucas.
It's Y, Y. Or does that matter?
Oh, no, that doesn't matter.
That was just.
Okay. So the letter Y means income. The letter C is consumption. The letter S is savings. And when we say consumption, we're talking spending. So how much of my check am I spending? According to this, it's 96%. Okay, 0.96. Now, since you can only spend or save your income, whatever you don't spend has to be savings, which means those two average propensities have to add up to 1. All right? But we can do the math anyway. So if we spent 48,000 of our income, that means we had to save 2,000 of it. And so the APS is savings over income. So 2,000 divided by 50,000 gives us 0.04. Okay? All right, cool. So far we're doing okay? All right. Do you think it's possible that the APC could be bigger than 1?
Yes.
Yes! Nice. You're good at nickel. You should give this to somebody who needs it. All right, fine. Yes, it's possible if you go into debt. Okay? So here we have the same individual, makes $50,000 a year, but they spend $52,000. How do you do it? You go into debt. And if you go into debt, that means your savings is now negative. Okay, guys? So we still do the same math. In this case, you got 52 divided by 50, gives you 1.04. And then negative 2 divided by 50 is negative 0.04. So these guys still add up to 1. That means everything's still good. Okay? Everybody follow that?
Wait, so what was that again? You spent over their paycheck?
Yeah. Yeah, they had a credit card, so they spent all their 50,000 and then bought 2,000 more with a credit card. Okay? All right. So the bottom line here, this is just the percentage of your income you spend, the percent that you save. Whatever these numbers come out to, though, they always have to add up to 1. Always. Can't be 1.1. Can't be 0.99. It always has to add up to 1. Everybody good? All right, cool. So now we're going to complicate it. So, Val, is it possible that you spend most of your paycheck, right? But then, whenever you get like birthday money and stuff, do you save a bigger percentage of that, or do you spend it just the same as you always did? You still spend it the same way. Okay, that's fine. Do you think everybody does that? No, most people don't. So when people get extra income, they generally will save a bigger part of it. Okay? Everybody get that? So that leads us to this thing, the marginal propensity to consume and the marginal propensity to save. All this means is marginal, it's just extra. So when we get an extra piece of income, we're going to spend part of it and save part of it, but usually in different percentages. So the way we calculate the MPC is this. We'll take our change in consumption, okay, and we divide by the change in income. So for example, if I have my regular income that I spend 96% of, but then, I don't know, I get $1,000 for my birthday, maybe I'm thinking to myself, I better save part of that. So instead of spending 96% of my new income, I'm going to spend 750 of it divided by 1,000. So the marginal propensity to consume is 0.75. Everybody follow me? Okay. Then NPS, that's just change in savings divided by change in income. And so if I spent 750 of my new income, that means I had to save 250. So 250 divided by 1,000 gives me 0.25. So these two numbers also always have to add up to 1. All right? Everybody cool with this? Okay, here's the part that you might get mad at me, but that last slide when we did APC, APS, those don't matter. Okay? When we're trying to boost the economy or figure things out with the economy, these are what we use. We have to know the MPC, the MPS. Okay? James?
Does investing count as spending?
Mm-hmm. Spending. Yep. Well, hold on. Do you mean financial investment like my retirement account?
No,
Like if I buy a factory?
no, if I could buy $1,000 in stocks.
Oh, yeah, yeah.
Savings.
That's saving. Okay. All right. Everybody cool with that then? Good question. That's spending. Okay. That's why I had to clarify with him. Because in economics class, investment is the purchase of capital. In financial, finance class, personal finance, investing is buying stocks. So you got, you know, different lingo, different languages here. Never have time, man. Never have time. All right, now we got to talk about this multiplier. Okay, for right this second, just write this stuff down. Okay, I'm going to explain what we mean by the multiplier, but for now, I need you to know this. There's actually 3 types of multiplier. We're going to look at 2 of them here. Okay, there's the expenditure multiplier. So this ME right over here, the M is multiplier, the E is expenditure. So we know which one we're talking about when we have the ME. Okay. To calculate the expenditure multiplier, you take the number 1 and you divide 1 by MPS. Everybody cool with that? Huh? MT is the other one. This is called the tax multiplier. The tax multiplier, you just take the ME that you already know and you subtract 1. Okay? So basically what these mean is this, okay? Let me give you a nutshell example of what this means, okay? If I'm the government and I buy $100 worth of something, what am I buying? I forget. Shoes. You're such a girl. Shoes. All right. So I'm the government and I'm going to buy $100 worth of shoes from Meredith, okay? Meredith now has $100 in income. That $100 in income, she's going to save part of it and she's going to spend part of it. And then you're going to spend it on what? Food. So she buys food from Emily, okay? Now Emily has this new income. And her new income, she's going to spend part and save part. And then she's going to buy what? Clothes. From Sophie. Okay? And so now Sophie has new income that she's going to save part and spend part. And we could keep going and on and on and on, okay? The point is this. When the government bought $100 from her, GDP increased by $100. Then when you bought you bought food from Emily, whatever amount that was, GDP went up by that amount. And then when Emily bought clothes from Sophie, GDP increased again. And so Keynes suggested that if we know what people are saving, then we can calculate how much GDP would actually increase given new spending. So that's what we mean by a multiplier. Okay? In fact, it's right here. It says that it tells us how much aggregate spending changes with a change in spending by the government. So that shouldn't be an and. Okay? I'm going to give you a bunch of examples to make this make sense. But like I said, for now, I just want you to get the formulas down. Lucas. Okay. The ME is the expenditure multiplier. Okay? And MT is the tax multiplier. Everybody good? Ready to roll? All right. So here's an example of what I'm talking about. Okay, the government spends $200 billion on highways. Okay, that spending becomes income for the highway workers. Okay, so now the highway workers have new income. And since the MPC is 75% or 0.75, we know that the highway workers are going to save 25% of that 200 billion. So they put 50 billion in their bank and they save it. The other 150 billion, that's the 75% of 200, they're going to buy boats with or something else. They're just going to buy something with it, okay? Then the boat makers, they're going to save 25% of the 150 billion, but they're going to spend the other 75%. See how this is going? And we just keep going over and over and over. But the effect is that we're going to increase GDP by every time we spend money, we're increasing GDP. So the 200 billion is the initial thing. That added 200 billion to GDP. Then 150 billion in boats. This is way uncalibrated. Okay. And then we got 112 or so billion. And we got all that up. What do we got so far? 350, 462 and a half. Okay. That's only through 3 iterations of saving and spending. If we continued this, see the iPod phone people, they're going to have $112.5 billion worth of income that they're going to save part of and spend part, and it's just going to keep on going. Okay? So eventually, according to Keynes, since MPC is 0.75, MPS is 0.25. That should be written in your notes, right? Okay? And the expenditure multiplier would be 4. So Keynes would suggest that this 200 billion would become 800 billion added to GDP. See how that's working? It's okay if you don't get it yet. Okay? Questions? Yep. You multiply the expenditure multiplier by the amount of spending. That will suggest to you that GDP will increase not by 200 billion, but by 800 billion. So here's a better example, okay? I've made the multiplier 0.5. I mean, the MPC is 0.5, okay? That means the MPS is also 0.5. Everybody get that? So MPS is also 0.5, which means the multiplier is 1 over 0.5, which is 2, okay? So we're going to demonstrate how it is that when Dallas County spends $1,000, the GDP of Dallas County increases by how much? 2,000, okay? So here's how it works. Okay, they buy hazmat suits, $1,000, okay? The hazmat suit workers are going to take that new income and they're going to go to Disneyland because they want to get out of town because you know what was in Dallas, right? Okay. All right, so then the Disney workers, they have all this new income. They're going to buy Labradoodles, okay? Then the Labradoodle breeders, they buy dog food. The dog food workers buy Frockets. And it just goes on and on and on. Okay, the apparel workers go to the movies. Notice the $1,000, half of it got saved. Okay, so then 500 got spent. Okay, so far we got 1,500 in GDP that all came from $1,000 in initial spending. Then the 250 goes to Disneyland. And so we get, what do we got now? 1,750. Then 125. See, it's just adding up. And if you keep doing this forever and ever and ever, $2,000 is what GDP changes by. Okay? That's how the theory works. Everybody get it? All right. So, Drew, when we talked earlier about the last recession and we spent $1 trillion to get out of it, this theory, I mean, it couldn't have worked because there's no way that we had, I mean, the multiplier would have had to have been like 1, you know? Yeah, so it's like, it's just very, this is the theory, and so this is how we have to learn it, and this is how you'll be tested. But just recognize that in the real world, some of this stuff doesn't actually go as cut and dry as we make it, okay? Because again, we're just teaching theory. All right, so now we're going to do some examples. We're going to put all this into practice. You guys are going to learn how to calculate everything, and we're just going to go down the rows, okay? So for example, we're going to have Meredith. You're going to start us off because I think I know that you'll get it all right, okay? So you're going to be the example. Before we do anything, we're going to remind ourselves to calculate MPS, we got to do 1 minus the MPC. Right, guys? because these two columns have to add up to 1. All right? Then the expenditure multiplier is 1 divided by the NPS. The tax multiplier is the ME minus 1. Okay? So far we good? By the way, another way to write this, it's also MPC divided by MPS. Okay? Now, what I've done over here, this is the confusing part. What I'm trying to illustrate here is that if the government increases spending by 20, whatever, just 20, how much does GDP really change by? And then, if they instead decrease taxes by 20, how much does GDP really change by? That's what we're trying to get at right now, okay? So Meredith, you're up. If the MPC is 0.9, what's the MPS? Okay. Yes. Okay, what's the expenditure multiplier then? 10. And what's the tax multiplier? Okay. Now the tricky part. If I'm the government and I increase spending by 20, how much does GDP really change by? Okay. We're not going to divide. So we have this thing's called a multiplier. This is spending. So we use the expenditure multiplier, 200, okay? Okay, so do y'all get that? What we're doing here is the government increases spending by 20, but because of the multiplier effect, GDP really increases by 200, okay? Because the income becomes saved and spent, and it's saved and spent over and over and over until the eventual change in GDP is 200. Is that cool? All right. Instead, we're going to reduce taxes by 20. So this one's a little more complicated. Y'all learned last class that if taxes go down, what happens to GDP? It goes up, okay? So that's why we put a negative sign here. But in reality, when we get our final answer, we're going to use absolute value instead, okay? So 20 times 9 is what you're going to use to change GDP now. So what is it? 180. Okay, do y'all see how that's working? Okay. Do what? Yeah, so that's, yeah. Okay. Lucas, I forgot, you asked a question, right? Yeah. No negative sign. So what we have to do is we have to rely on our learning from last class, that if taxes go down, GDP goes up. If taxes are raised, GDP will go down. Okay, so you just got to keep that in mind. All right, Laura. Mm-hmm. Cool deal. But keep in mind, this 20G, all I'm saying is that this amount of spending will increase GDP by that amount. Okay? So that's all it is. I didn't want to be confusing, but maybe I just did. All right. You want to go next? Good. All right. So the MPC is 0.8. So what's MPS? Okay. Whoa. 0.2. Hey, wait a minute. This writes on the... it writes on the other side, too. Wait. It writes like that, too. Okay, sorry. It's like a new toy. All right, Laura, what's the expenditure multiplier? 5 it is. Bueno. Tax multiplier. Okay. So now we increase government spending by 20. How much does GDP change by? 100 is perfect. Good job. But instead, we reduce taxes by 20. 80. Tell her. Thanks, Steve. All right. If they raise taxes? No. If they raise taxes, GDP is going to go down by 80. Yeah. So you just use 20 every time. Wait a minute. What are we?
Well, did you say that for like the employee sheet, like you can just subtract 20 and get your take home?
Oh no, that's not what I said. No, but that's the effect. Okay, the effect is the same because the tax multiplier is 1 less, which means it's 120 less, $120 less. Okay. So yeah, I mean it's essentially the same. Okay. All right, Justin, you're up. 0.25. Good job. Four is correct. $80 is correct. Why'd you have to guess? Okay. All right, gotcha. Jeopardy style. Okay, I got it. Let's see. I'm going to do something here.
Wait, is it 60?
Yes. So we're multiplying that to get the 80. And then we take our 20 in tax cuts. Whoops, I screwed that up. Okay. When we get changes in spending, we multiply that spending by the expenditure multiplier. When we get changes in taxes, we multiply that by the tax multiplier. And so what'd you get, 60? Okay. So if you reduce taxes by 20, GDP goes up by 60. Cool? All right, anybody want to guess why the tax multiplier is smaller? Oh, yeah. Sorry about that. We pass it back. Anybody? Why is the tax multiplier smaller? All right, I'll just tell you. So if the government gives me $20, okay, did GDP change when they did that? No. Okay. But as soon as I spend the $20, it will, but I'm going to save part of it. So the tax cut doesn't change GDP by as much as the spending. Okay. So that's why it's smaller. All right, one more? Or are y'all ready to move on to other examples? James wants to do it? Okay, go. Oh, I'm sorry, Kennedy, did you say? Y'all can do it together. Y'all can, like, I'll give you each half a nickel. Let's let James do it. He really needs to practice. Okay. 0.4 for the MPS. Good. 2.5 is correct. 1.5 is absolutely right. 50, yep. If I increase spending by 20, 50 will change GDP. 30, okay. Good. Kennedy, is that exactly what you were going to say? Okay, good. I can't get it out. There, will you pass that back? Okay. So let's move on, and Kennedy, you do this one. No, it's not. It's a total word problem, though, and you got to calculate everything, okay? So we got some Aggie students at Padre, living the good life, okay? Everything wholesome, having a good time. Okay. Yeah, good family fun. So during spring break, college students go to Padre. They spend money there, don't they? Okay, when they buy drinks and food and hotel rooms and whatever else they're going to do, they end up increasing the income of the people in Padre. Everybody agree with that? Okay. So here's our question for Kennedy. If the students spend $8 million at Padre for spring break, and the MPC in Padre is 0.6, then college students will increase income in Padre by how much? And when I say increase income, I'm talking GDP. Okay? Go ahead. Word problem. Do you? Okay. So she does need to figure out the NPS. Okay. So that's step one. 2 more steps. Yep, 1 divided by 0.4 gets her multiplier. You got this. No. It's the expenditure multiplier, 2.5. It's just that, just 2.5 times 8. 20 million, see? You'll have to do that type of thing on your homework and tests. Okay? All right. So let's roll on. I got a bunch of little examples, okay? Before we do the examples, though, I want to show you the chain reaction of fiscal policy. By the way, everything we're doing right now, it's called fiscal policy, okay? When the government spends money to boost the economy, or they cut taxes to boost the economy, we call that fiscal policy. So here's how it works. This economy's in a recession. Everybody recognize that? Okay. Because the equilibrium's to the left of the long-run aggregate supply curve, it is in a recession, okay? So to fix this, the government's going to increase spending, all right? When they increase spending, the aggregate demand curve shifts to the right, okay? And when it shifts to the right, it has formed a new equilibrium. Now GDP is higher, unemployment's lower, the price level went up a little bit, so that's how we fixed it. Pretty simple, right? Instead of increasing spending, we could also cut taxes, because when the government cuts our taxes, we now have more money to spend, right? We call that our disposable income increasing. That's going to lead to more consumption, which will shift the AD curve as well. And then we get the same thing. Cool? It's not too bad? All right. Now, there's complications when this happens, okay? And I don't have time in class to show you the complications today, so we're going to do it next time. But just be aware that whenever the government increases spending, interest rates go up, okay? And that's basically what the complication would be. So next class, we'll talk about that. Now we're going to look at some examples, and here it is, okay? We've got an economy. It says here this economy is short of full employment equilibrium by $60 billion, okay? So as a drawing, this is what the economy looks like. Everything's labeled pretty. Price level. Our long-run aggregate supply curve is here. This equilibrium is 800. It's supposed to be at 860. So far so good? All right. We're given some information. We're told that when income changes by 1,000, consumption changes by 900. Okay? So what's savings change by? 100. So just fill in the blanks here. These are all the things you need to know in order to figure out how to fix this economy, okay? Parkour. What's our MPC? Okay, look at this. if you didn't write it down, I put it up here for you. Okay? Change in consumption divided by change in income. So it's basically this. Nope. Keep going. 0.9. Okay. Then NPS is 0.1. See, this is good. Okay. 10. Yes. And that is 9. All right. Cool. So, how do we fix the economy? This is where you have to. You got like a hidden piece now that you got to apply what you learned.
So is this when you do?
Yes. Let's see if he gets it. No, you're really close. Here's what I have: the Walden rule. I'm going to write it out for you. Okay. It says that your change in GDP will equal your change in government spending times the expenditure multiplier. Okay? Or your change in GDP will equal your change in taxes times the tax multiplier. So, what you're given in this example is you're given how much you want GDP to change by. So you want it to change by 60, right? Okay, so I want GDP to change by 60. And I also know our multiplier is 10. Okay? So 10 times what will give you 60? 6. That means if we increase government spending by 6, AD will shift right like so and fix the economy. Okay? But you can also change taxes. So in that case, here I'll make that a different color. So we want GDP to change by 60. Our tax multiplier is 9. And so what 9 times what will give you 60? I don't know. 6.6? Something like that? Okay. I'm going to trust your math because I don't know for sure. So we could reduce taxes by that much. Okay? That's how you fix the economy. So far, so good? It's not so bad. Should I give him a nickel for that? Okay. All right. All right, next. Yeah, that's a good one. Set the clock ahead. It's like 5 o'clock. Oh, sorry, Chris. They were plotting against you. I stopped them. All right. Now we have an inflationary gap. Okay? What's that look like? It looks similar. There's a gap, but this time our GDP is too big. Okay? Ordinarily you would say, oh, GDP getting bigger, that's a good thing, but it's led to a lot of inflation. So we call this an inflationary gap. Okay? And it says the gap is 200 billion. Okay? So the size of the gap is 200. So what do you want GDP to change by, guys? 200, okay? So we're given information again. Okay, consumption's 80, or the change in consumption's 80, the change in income is 100. Okay, so the change in savings is what? 20. MPC, 8 over 10 basically, is 0.80. What's MPS? 0.20. So our expenditure multiplier then is 5. Tax multiplier is 4. Okay? So you'll be asked on your homework in a test, how do we fix this economy? Okay, we're going to want to change government spending by how much? Yep. You said 200, right? No, it's none of those. Here's why. If we decrease government spending, AD will shift left, right? So that's what we want to do. But if we do it by 200, it becomes 200 times 5, which is 1,000. So AD would come way over here. And now we're eating each other because the economy fell apart so badly. Okay? So, yes. So even though it's a multiplier, if we know the gap, we're actually dividing by the multiplier. You get that? So what Kennedy said is that we want the gap to, or we want to change GDP by 200. So we've got to change spending by whatever times 5. So 40. But then we got to remember we want AD to shift left. So that means we have to decrease government spending by 40. Okay? That's a G. It's an ugly G. Okay? Are we okay there? So the reason it's 40 is because 40 times 5 gives us 200. Okay? All right. We could also do it with tax cuts, or tax increases, rather. Okay? And so now we can take 200, divide by 4. So if we raise taxes by 50, either one of those things will shift the AD curve back to our full employment level, and we have fixed the economy. Cool, guys? All right. You have to do all of this. Yeah. Did I tell you all at the beginning of class to draw the grid? Okay. On your homework, there's a little grid that you have to fill in. It's like columns and stuff. You just replicate it on paper, because if you don't, you're going to be very sorry. It's going to drive you nuts. All right. Got one more? And then, let's see, do we want to do this one? You know what? I want to show you all something different. This is what I want to show you now. Okay. So we've fixed a recession. We fixed inflation. We did that with increases and decreases in spending or tax cuts. Okay. But now we're going to do something a little bit different. All right. So it says here that we've got current GDP is 2,000, but the unemployment rate is 12%. Okay. Full employment GDP is 2,500. So what's our GDP gap? 500. Is it a recessionary gap or an inflationary gap? Okay, it's a recessionary gap. So let's draw it, see what it looks like. All right, I'm drawing this out. Got all my labels on it, so it's pretty. This is our long-run aggregate supply curve. It says here that our full employment GDP is 2,500, so this should be 25. And right now, it's 2,000. So our gap is 500. So we want GDP to increase by 500. But it says here that the policymakers do not want to increase the debt. So we have to do this a little bit differently. So let me introduce you to this concept, the balanced budget multiplier. All right, you ready for this? Okay, you might need to write this down. Balanced budget multiplier is 1. Okay? So what does it mean by that? Here's what it really is. If we take our expenditure multiplier and subtract our tax multiplier, okay, let's say this is 5 and this is 4, you get 1. Here's what it means, okay? Let's pretend that these are indeed our multipliers, okay? Expenditure multiplier is 5, and the tax multiplier is 4, okay? So if I wanted to fix this economy, the balanced budget multiplier tells me it's 1. So what that means is if we have equal increases in spending and taxes, that amount will change GDP 1 time, okay? So if I want GDP to increase by 500, that means I want to increase spending by 500 and raise taxes by 500. So let's demonstrate. If I just do the spending of 500 and the multiplier is 5, that means GDP is going to increase by 5 times 500. It's going to go way over here, okay? And now we're at 4,500, okay? But if I also raise taxes by 500, okay, 500 times 4 is 2,000. So this aggregate demand curve is going to come backwards by 2,000. That was 2, okay? And now what are we at? Yeah, we made it. So equal increases in taxes and spending by 500 will close this gap because the balanced budget multiplier is 500. And by the way, it's called balanced budget because there's no borrowing that has to take place. Okay? If we tax by 500 and then spend the 500, there's no borrowing. We have a balanced budget. I took GDP was 2,000. Okay, where's my arrow? GDP was 2,000. Then I spent $500 times 5, increased GDP by 2,500. So it went from 2,000 to 4,500. Okay, that's the first round. Then the tax increases reduced GDP by 2,000 and brought us back to equilibrium.